Alright, here we go. Notes for 5.1. The first thing we want to talk about is stuff that we needed from first semester. So, bisectors, BI. Okay? When we had the angle or the alternate interior angles with those parallel lines, right? So when we had these parallel lines, we had alternate interior angles, alternate exterior angles, alternate interior angles, corresponding angles, same side interior, same side exterior, vertical angles, okay? Supplementary angles were angles that added up to be 180. So when we take a look at these same side interior, those were 180 degrees, right? But like we were pointing out earlier, that a linear pair is also 180 degrees. And these are two huge things in geometry we need to really be able to understand. Is that two angles that form a line are 180 degrees. Right? Okay, and then we had that the 90 degree thing where, you know, we had two angles that created 90 degrees. Okay? So that's huge. And then we have these symbols. And we use these symbols a lot. Okay? So if you might want to pause the video, take these down because you have perpendicular, parallel, if, then, and came up with this biconditional then. Later on, we forgot to write it, but it's tied to this then. That just means it goes both ways. Okay? And, or, intersects, not, angle, triangle, congruent, and segments. Okay? So this is the stuff that we went over first semester, and now I'm going to erase it.
We got like 7 minutes.
I know. It's not a lot of time. Ho, ho, ho. Okay, so we don't need this. So we're going to talk about these 3 problems, 12, 13, 14, in the next 7 minutes, but also about these bisector notes. So the bisector notes are as such. If you have a perpendicular bisector, right? What does it mean to bisect? It means to cut in half. If you cut something in half, it's supposed to be equal, right? So if your mom ever said, hey, you and Johnny can cut that candy bar in half, Johnny gets to cut it in half, and then you get to pick which one you want, right? And that way Johnny's like not going to be like, here's the big half and here you get the small half, right? Because you want it to be equal, okay? So bisectors cut it in half so that they're equal, all right? So the key here is that if this is a perpendicular bisector, right, it means that it's cutting this in half, and it also means, and I don't know why I didn't show this, but maybe it just doesn't show it. No, it does. Is that it also means that this is a perpendicular. Okay? So 2 things happen. 1, this is 90 degrees. So that means this is 90 degrees because it's a linear pair, right? But 2, this side is congruent to that side. So that's huge. If I know this is 10, then this is 10. That's all we're saying. If we know it's a perpendicular bisector, both sides are the same. Right? So you know where they're going with that, okay? Now here's the other thing about a perpendicular bisector. Okay? That means these sides are going to be the same. And so I don't like to do 2 pictures. I like to do just 1. Okay? So I'm going to show you the one picture that I like to do, that I normally do for my students. Okay? And what I normally do is I say, hey, if this is a perpendicular bisector, then these 2 are congruent, right? Yeah. But also, these 2 are congruent. Now think about that. Think about that. Okay? know it's a right triangle, right? Then we know these two are congruent, right? CPCTC, right? Because of why? Oh, because of angle side side, right? Or hypotenuse leg, right? We have a leg, we have an hypotenuse. So angle side side only works if it's right, okay? So that these two triangles are the same, or congruent. Okay, so we didn't write those down. Remember those 5? So angle, angle, side, side, angle, side, 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 angle, side, angle, and then of course our favorite one, which is angle, side, side. But it's only true if the triangle is right. Okay? So this one's special. Of course, you know, angle side side's always special. Okay? So, there we go. So that's your perpendicular bisector. I would highly, highly, highly suggest using that picture versus 2 pictures showing the same thing. Does that make sense? Okay? Alright, in the same aspect, the book likes to give you this. Well, we have what's called an angle bisector. This was a segment bisector, right? A special segment bisector, perpendicular bisector, okay? But this is what we call an angle bisector. What an angle bisector does, it's so freaking important, okay? An angle bisector does this. If I bisect this angle, then any point on this line, any point on that line that creates a perpendicular with the other 2 lines makes those 2 lines congruent. Okay? Makes those 2 lines congruent. Now let's think about this for a second. That means I cut that thing in half, right? Okay? I take any point, I don't care what point, I take any point on that line and I draw a perpendicular and I draw a perpendicular. Okay? Now these are perpendicular and these are congruent. Think about that. What did we have before? We know that these are congruent, right? This one's just it's sharing, right? So by that reflexive, right, or symmetric property, depending on how you're looking at it, okay, this has to be congruent to itself, right? So what do we have? Angle, side, side, and it's a right angle, correct? That means those 2 things are congruent. What else does it mean? It means that this is congruent to this. It means that this is congruent to this. And the same with this guy. If this is 2 congruent triangles, that means that this must be congruent to this, that this must be congruent to this, that this must be congruent, oh hello, and this is congruent to itself. So it's making 2 congruent triangles. Okay? I'll do the rest of this on the YouTube, and then you guys can pick it up later. Alright, so let's finish 12 and 13 while they're at lunch. Breakfast, whatever. Alright, so 12 is T is a perpendicular bisector of JK, which means that it bisects this in half. So that tells me this. That tells me that these have to be congruent. So I know that this is congruent to this. Okay? Now, if I know that this is a right, then this has to be right. This has to be congruent to itself. So I have hypotenuse, leg. So that means that this is congruent to this. And this is congruent to this. and that this is congruent to this. So no matter what I do, then GK has to be congruent to GJ. So that means this is 8.25. JG has to be congruent to KG. So that means that x plus 12 has to be equal to 3x minus 17. Why? Because, well, there's a lot of reasons actually. So, first of all, you had your first step is that they are bi. Your second step, so we would have had to gone through all of that. So, I'll do that another day. We already proved all of that. So, we're just going to say that because of HL, or angle side side, okay, and then now we can do our math. That means I'm going to move my lowest x, and I got 12 is equal to 2x minus 17, okay, and now I have, well, that's subtraction property of equality. Next, okay, I have plus 17, so I have 929 is equal to 2x, okay, that's the addition property of equality, okay, and then I have the division property of equality, meaning that this is going to be 14.5 is equal to x. Okay. So, with that said, then they want to know what kg is. I'm going to have to multiply that by 3. So I plug it in. 3 times 14.5 minus 17. 3 times 14.5. Make sure I did that right. So that's 9, that's 29. Okay. So that would be 30 plus 12 plus 1.5. So we're going to have 42, 43.5 minus 17. And so we have substitution. Okay. And then we have simplification. Okay. And so our answer is, well, 17, 2 from 3 is 1, 5 from 1 is 6, we're at 36, and so 26.5. So that would be our answer. 26.5 for problem number 13. Okay.